Now we will see like what is the relation between empirical formula and to the final formula. So, for example, like if you take magnesium oxide. So magnesium oxide, its empirical formula is actually MgO. If you look into its molecular formula that is also magnesium oxide only. So in this case, empirical formula and molecular formula both are same. But this is not the case with all types of molecules. Okay, for there are some molecules, if you look into its empirical formula and molecular formula, they both will be different. So we shall see how to convert empirical formula to molecular formula. We will see how we can convert empirical formula to molecular formula. Okay. For example, yeah, if you are looking into probably, okay, if you are looking into probably, H2, H2 hydrogen peroxide. So, the empirical formula, it is nothing but the simplest ratio of the molecules. See, for H2O2, actually its empirical formula is actually HO, because you can divide both by, divide by 1 by 2, or sorry, you can multiply by 1 by 2 or like a divide by 2. So you will get actually H, H2 by 2, O2 2 by 2. So this is going to be HO. Okay, so this is what the empirical formula is. Okay, next one is probably, let's see the relation between empirical formula and molecular formula. See, what is the empirical formula mass here? Empirical formula mass, actually it is 1 into 1 plus, because if you take for OH, so it is a 16 into 1. So this is going to be 1 plus 16, so this is going to be 17 gram. Okay, and so molecular formula is actually, this is going to be H2O2. So its a molecular weight is equal to 2 into 1 plus actually 2 into 16. So this is going to be 2 plus 32. So you will be getting 2 into 16, it is going to be 32, right? So 32 plus 2, it is going to be 34. So its molecular weight is going to be 34 gram, and empirical formula mass is going to be 17 gram. So how we can find, if you know, like a molecular weight, and once you come to the empirical formula mass, so like the relation is actually empirical formula mass is equal to 34, molecular formula mass is equal to, empirical formula mass is equal to 70, molecular formula mass is equal to 34, molecular weight is equal to 34. So the digit n is actually 34 divided by 17. So this is, you are going to get a 2. Okay, so you are going to get a 2, and yeah, so this is what it is. Now you already know the empirical formula, so that is actually, this is going to be OH. So into 2, you will be getting H2O2. Okay, H2O2. So this is the case. This is the empirical formula mass. Now, yeah. So the empirical formula actually, like how we can find actually the relative atomic mass and empirical formula is. See, you can find n value. N is actually molecular weight divided by empirical formula mass. Okay, so this is a digit. Like with the n, if you multiply empirical formula into n, this is, you are going to get a molecular formula. So please remember this particular concept. Okay, so this is how you can find it. And probably if you take another example, okay, we will write it here. we will write in this particular place. See, you know this C2H4. So write C2, yeah, let it be C2H6. See, what is the empirical formula here? Empirical formula is actually, you can divide by 2. So you will get CH3. So this is the empirical formula. And if you know the empirical formula mass is actually 12 plus, because that is the atomic mass of carbon, 3 into 1. So this is going to be 12 plus 3. So you will get around, 15 gram you will be getting. So that is the empirical formula mass. Okay. And molecular weight, we don't know. We will find the molecular weight. So this is going to be 2 into 12 plus 6 into 1. So 2 into 12, 24 plus 6. So this is going to be 30 gram. Wow. So yeah, 2 into 12 24, 6 into 1, it is going to be 24, right? So the n value, it is going to be 30 divided by 15. So you will get around 2. Okay, you will get around 2. So the n value is, okay, I shall write here. N value is actually 30 divided by 15. So you will get around 2. Okay. Okay, so this is how, the n value is coming. Okay, and now if you multiply, what is the empirical formula here? Empirical formula is going to be, okay, I will write, there is space. Okay, I shall write here. Empirical formula is actually CH3, and molecular formula is going to be 2 into CH3. So this is going to be C2H6. Okay. So 2 into C2H6. So this is going to be the empirical formula. So if you just know, it is pretty easy, the relation between empirical formula and molecular formula. First find the, empirical formula mass. Empirical formula mass, you can find empirical formula mass. Then if you know the molecular formula, you find the molecular weight. So empirical formula divided by n is equal to empirical formula mass divided by molecular formula mass. You will get n. If you multiply empirical formula into n, you will get a molecular formula. So this is the relation. Okay. Okay. You take octane, so which is a hydrocarbon. So now the question is, it contains 84.2 percentage of carbon, and remaining percentage 15.8 percentage of hydrogen. Okay, so this is the case. So they are asking you to find the molecular formula, and so here actually a molecular weight that is going to be so 114. Their question is, they want you to find the molecular formula. Okay, so here actually number of moles we can find 84.2 divided by carbon, it is actually for a total. So you will get maybe, I don't know, so number of moles of hydrogen we can find from 15.8 divided by 1. So this you will get around 15.8. Okay, so now 84.2 divided by 2 total, so you will get maybe around 7.02 moles. Okay, so this is how you will be getting. Now the next thing is, in order to find the simplest ratio, we can divide everything by the smallest number. In this two case, this is the smallest number, 7.02. So that is the smallest number. So here actually for carbon, it is actually 7.02 divided by 7.02. You will get 1. Here for hydrogen, it is going to be 15.8 divided by 7.02. So you will be getting roughly around roughly around 2 2.25 you may get. Roughly around 2 you will be getting. Okay. So roughly around 2.2 you may get. So we can round it into CH2. CH2. So the empirical formula is see here in this empirical formula is CH2. What I got is CH2. So empirical formula mass that is 12 plus 2 into 1. So this you will be getting 14. So 14 you will be getting. Okay. Now we will see like a number of n, that is actually, so it is actually 14. I am not sure how much you will get. Calculate around 8.14. Okay. So empirical formula is CH2. So molecular formula is 8.14 into CH2. Okay. So C8H16, not 16. So C roughly around 8.14 into 2 you will be getting C17, close to C17 you will get. So we can round it into 18. Okay. So this is how actually the empirical formula you will be getting. Okay. So if we are counting correctly, like this is going to be, now when you are multiplying, like 8.14 into 2 you will be getting 16, close to 17 you will get, but here if you do the calculations a little more properly you will be getting C8H18. So the molecular formula of octane is actually C8 C8H18. Okay.